For the uniform 5 kg beam shown in figure, how large is the tension in the supporting cable and what are the components of force exerted by the hinge on the beam? Beam weight is mass is 5 kg. Okay. Now let's make the free body diagram of this beam. So this beam is being exerted by a horizontal force, say Fh, in this direction and a vertical force in this direction, and this is what we have to find out. What are the components of force exerted by the hinge on beam? So I made like this. Not necessary that Fh will be like this and Fb will be in upward direction. They can be in opposite direction as well, but that is not important for us to know before solving it, because if we are taking a wrong direction, then we'll get a minus sign in the end. Apart from that, we have a 50 Newton weight just at the middle. This beam is 140 centimeter long. So this will be acting at 70 centimeter, 0.7, and then we have a tension at 100 centimeter. This is T. Let me take this tension as T1, this as T2, and we'll have the components in this direction. T2 the vertical component, T2 the horizontal component. Now we have made all the components. The beam is stable in equilibrium in force as well as torque equilibrium. So let's first write the equation for force equilibrium. So in the vertical direction, we can write Fv, and this is plus T2 sine 37. Vertical should be equal to 50 is downwards plus T1, and T1 you can easily write T1 is equals to 100 Newton. 100. So we get Fv plus T2 3 by 5 is 150, or Fv plus 0.6 T2 is 150. This is my first equation. Now let's make the equation for what? Horizontal. In horizontal direction, Fh, and that's only one force, which is equal to T2H. That is T2 cos 37. So Fh we get as 0.8. T2 cos 37 is 4 by 5. Now we cannot still solve the tensions and forces, because there are three unknowns, Fv, Fh and T2, and two equations. So now we will be requiring a torque equation about this hinged point. Torque about a hinged point will be Fv, the line of force is at the hinge point, so into 0. Similarly, Fh is also at the hinge point only, so into 0. Then plus this is downward force, and what we do is we take a r vector and then we rotate r cross f. If it is clockwise, we take a negative sign. Okay, let's take a negative sign. R is 70, 0.7 into 50, and we'll take a negative sign. Inside the plane of paper is clockwise, so you can also take minus k cap if you're writing in vector form. And then we have this force T2 vertical, that is 0.6 T2, and see, this is R is anti-clockwise sense going to T2V, so we'll take a positive, and this is plus 0.6 T2 into distance is 100, so we'll take 1, and finally is T1, that is again a minus clockwise, so we'll take 1.4 into 100. That entire torque must be 0 because it is not rotating, it it is in torque equilibrium. 0, this is 35, all negative I'll take here, I'll keep it here only, 35, and I'll remove the k as well. This was k, I'll remove the k, this was plus k, because we just need the magnitude now. 35 and plus 140, these two are in one direction, so we'll get 175. 140 and 35 is 175, and here we have 0.6 T2. So T2 is if we are able to solve using this equation, 175 divided by 0.6, or you can write like this as well. So T is 6 to the and 6 9s are 54, and 1 6 1s are 0.6 Newton. So we got T2, and then we can also find out my FH, which is 0.8 T2, 0.8 into 291.6. So I'll get approximately, just subtract 54 from 291, 241 into approximately 235 Newton approximately I'll get as the horizontal force, and vertical force I'm getting, I'll write here only, FV is equals to 150 minus 0.62. 0.6 into 291.6 will be, you can easily calculate it, 291.6, 36, 6, 54 and 12, 6, 9, 4, 7, 174.96. So we'll getting 174.96, so I'll get minus 24.96. The negative sign shows that the the vertical force is actually downwards. Okay, this is a 24.96 Newton, and this FH is coming out to be 235 Newton. So the entire force can also be written like it is acting in this direction, and we can easily find out the angle with the horizontal at which the hinge point is applying force. So we have got the answers. We have got T2, FH and FV.